Mathematics, Grade 10, Lecture 10. Today, I continue talk about Sine Law, Cosine Law, application to geometry, and examples, the second example in the series. Example 1. I have a right triangle another triangle which is not right triangle, and 400. I have a right triangle, 18 degree, another triangle which is not right triangle, and this side is 400 meters, 20, excuse me, 27 degree, 35 degree. I want to find y. Excuse me. First, I use sine law. So I write sine law now. 400 divided by the sine of this angle. This angle is 180 minus this minus that. So this is my sine law. 400 over sine this is equal to this side. Okay, let me label this side as x. Is equal to this side divided by sine of 27 degrees. Okay, so what is y? So I must find x first, and then I can find y. Because y divided by x is tangent 18 degree. Therefore, y is x multiply 18 degree as tangent 18 degree. Okay. So this is what I have. From the sine law, I find x. Yeah, maybe I should stand here. From the sine law, I find x. From the definition of tangent 18 degree, and once I have x, then I can have y. So this is how you find the unknown y. So put everything into the formula. So y is equal to x. X is okay. X is 400 400 multiply this, and then followed by tangent 18 divided by this. This is the sine law. Find x, put x into here, you can find y. So x is 400, multiply this. And then you have to multiply that, so that gives you the numerator, 400 times sine 27, and then multiply tangent 18. Then you have to divide by this part. So this gives you y. You can use your calculator doing this part in one step. And this is what I usually recommend. Use your calculator very efficiently in one step. The advantage of this is that your calculator will keep all the decimal points for your answer. So, what is my answer? $66. So my answer is this. I have all the decimals given by my calculator. So you can, of course, you can round it up. Okay, so it's up to you. You can round it up. So this is how I find my y. Example 2. I have a right triangle, 90 degree here. This side is what I want to find. How long is y? And I have another triangle which is not right triangle. I know this angle, this side, that side. To find y, I must find x first. And then I can use the ratio y divided by x is tangent 49 to find y. So I must find x first. To find x, I use what? I have two sides and one angle. So to find x, I use cosine law. Sorry, I have to squeeze my writing here. To find x, I use cosine law. Remember cosine law? If you call this c side, c squared is a squared plus b squared minus 2ab cosine angle c. That's a cosine law. You take the square root. So that gives you the x. Now once you have the x, then you use the tangent ratio y over x. Y over x is tangent 49, therefore y is x tangent 49 degrees. Therefore, how do you find y? You find x first. From this cosine law, find x and multiply tangent 49, you get y. So I need more space here. So y is equal to x is this. I just copy this writing. This is my x. Then multiply tangent 49. So multiply tangent 49. And this gives my y. So use your calculator in one step. Be very careful. How do you do this in one step? Okay, be very careful. You need to practice using calculators. So the answer, the final answer is so this is my final answer. I want to mention it again. Use your calculator very efficiently in one step. But be very careful, okay? Yeah. If you do it in one step, you need to be very careful in doing that. If you do not like doing this in one step, you can write each step separately. There is nothing wrong with that. Yeah. But I just like to show you that you can do that using calculator in one step. You can do that. Okay. So next, example 3. I have a right triangle. I know this angle is 8 degrees. This 8 degree is this angle. 8 degrees. These two sides I do not know. I write it down. I use a label y, x. I have another triangle which is not a right triangle. This angle is 85 degrees. I know this side 80 meters. I know this angle 30 degrees. I want to find y, just like what I did before. Find y. Y is what? Y divided by x is tangent 8 degrees. Once I know x, no, I cannot find x here, all right? Yeah. So I need to find x using this. Okay. I can use sine law to find x. X divided by sine 30 degrees is this side divided by sine of this angle. But this angle is 180 minus 30 minus 85. Using sine law, this side over sine this angle is this side over sine this angle. That's my sine law. Using this sine law, everything is known except x. So I can find x. Once I found x, I put x here, I can find y. It's very similar to the first two examples. So y is y is x multiplied tangent 8 degrees. So it's x is this. You move the tangent, you move the sine 30 degrees to this place, divide by that, that is x, and then multiply tangent 8. So that is by y. Use your calculator in one step. So this is my answer. And you can round it up as you like. So it's not much different from example 1 and example 2. It's not much different. It's the same thing to use sine law, cosine law. All right. Next example. Now this is a three-dimensional diagram. Because it's a three-dimensional diagram, this triangle is a right triangle, but in 3D view, this doesn't look like 90 degree, but it is actually 90 degree. This is a right triangle, this is a 90 degree. In three-dimensional view, it is somewhat distorted. It doesn't look like 90, but it is actually 90 degree. You need to get familiar with looking at 3D drawing, okay? So this angle is 95, this side is 14 units, this side is 15 units, this side is 18 units. What do I want to find? I want to find the top angle, this. What is this angle? Let's call this angle theta. I want to find theta. Now, to find theta, because theta is in this triangle, and this is not a right triangle. So how do I find theta? Then I can use cosine law. I must find this side, I must find this side, and I must find this side. I need three sides to find the angle theta. So this side is easy because it's a right triangle. You use Pythagoras theorem. This is a right triangle. To find this side, you use Pythagoras theorem. So let's do the easy ones first. Let's label this side is A, and this side is B, and this side is C. So using Pythagoras theorem, B squared is 14 squared plus 15 squared. Pythagoras theorem. What about C squared? Pythagoras theorem. 15 squared plus 18 squared. Now I need A. So A, you have to use cosine law. So A squared is equal to B squared plus C squared minus 2BC cosine. This is the angle I want to find. So, from this, I find B. From this, I find C. Once I have B and C, put B and C here, B, C, and also B, C. Let's see now. I need A, right? From this triangle, I have cosine law. And from this triangle, I also have cosine law. You see? And in this triangle, I have cosine law. So A squared is 14 squared plus 18 squared minus 2 times 14 times 18 times cosine 95 degree. So now everything is there. From this, I find B. From this, I find C. From this, I can find A. So I know A, B, C. I know A, I know B, I know C. So I know B, C, but I don't know cosine theta. That's how I find cosine theta. Okay? Now, you can express cosine theta using all the given numbers and do this in one step. I don't have enough space here now. Let's see. Should I tell you how to do this? How to find cosine theta in terms of everything else? Let me think. Okay. But the principle is so simple. You find A here, you find B here, you find C here, put A, B, C into here, and you can find theta. So that's the principle, except that I showed you up to now, I showed you how to get the expression of your final answer and then use a calculator in one step. I don't have enough space to write this, and I want you to try. So the final answer is theta is okay, this is my answer. Okay. You try this as an exercise, how to write cosine theta using these relations, and it's a long expression. Once you have that long expression, use your calculator to find the cosine theta, and once you have the answer to cosine theta, you use second function cosine theta, that means the arc cosine, and then you can have the answer there. Next example. Example 5. It is also a three-dimensional drawing. All the sides are given. 20 units, 20 units here, 20 units here, and 12 units, 12 units, and 16 units here, 16 units here. So one thing special about this question is, in this triangle, it's isosceles because 12 and 12. In this triangle, again it is isosceles, 20, 20. In this triangle, it is isosceles, 20, 20. And in this big triangle, 20, 20. So all the triangles are isosceles. And how many triangles you do have? You have 4 triangles. You have 4 isosceles triangles. So let me draw this now. So you have 12, 12, 16, which is this, 12, 12, 16. Yeah, okay. And then you have 20, 20, 12. And you have two identical ones, 20, 20, 12. Two triangles identical, 20, 20, 12. 20, 20, 12. And you have one more is 20, 20, 16. 20, 20, and 16. Okay, in this question, what do I want to find? Find the total surface area. You have 4 triangular surfaces. What is the total surface area? You add the 4 area of the triangle and you add them up, and that's what you want. Now these 4 triangles are quite special because it's isosceles. How do you find the isosceles triangle area? Okay, suppose I have this. Isosceles, right? So A, B, C. And A, B, and C are the same. So B and C are the same. So what is the area? Area is 1/2 base times height. The area is 1/2 base. Base is A times height. Height is this. So how do you find height? You find half of A, which is this, and then you do Pythagoras theorem. B squared minus this square, take square root is H. So H is the square root B squared minus A over 2 square. Do you follow this? Let me stand on this side. So if you have an isosceles triangle B and B and A, this is H. So the area is 1/2 times the base A times the height. But the height is square root B squared minus half of A squared. So this is how you find H. So you do everything like this, and then just add the 4 areas. So you got it? So let's do this now. I don't need this because I have all the triangles here. So I have area, total area is 1/2 this, which is 8. So let's do it quicker. So 1/2 of this is 8. Times the height, which is square root 12 square plus, minus 16 minus 8, because that's, minus 8 square, take square root, that's the height. So this is 1/2 of the base, this times this, 1. And you see this is 1/2. Okay. This is 8. But the area is 1/2 the base, which is 8, times height. This is the area of the triangle. But I want area of this triangle, so you have to multiply 2. So you multiply 2, the 2 cancels. Do you see that? This is the area of the whole triangle. This is the area of this triangle. And the area of this triangle is equal to this triangle. So I add 2 times this. Now you see that the triangle is half of the base times height. So half of the base is 6 times height. $20 and 6. That is the sum of the area of this triangle and this triangle. Finally, I want this triangle, the area, so half of this is 8 times the height. Height is 20 and 8. So that is my expression. 4 triangles. 1, 2, 3, and 4. So my final answer, use your calculator. This is easier to do in one step. So use your calculator so you have the answer now. Okay, this is your answer. Final answer. So this is all I want to say in this lecture. So I have 5 examples. All of them are 3-dimensional triangles. And it's not difficult. You use sine law, cosine law. The principle is not so difficult. Okay, I just want to show you in the first 2 examples how to do this using calculator in one step. Okay, if you don't like doing calculator in one step, you can write each step. Yeah, there's nothing wrong with that. Okay, that's all for today's lecture. Goodbye. See you next.